Hi guys, Mr. Sonnenberg here. This is part 2 of environmental issues and concerns with regards to pesticide use. This is, again, Science 9 Environmental Chemistry, topic 2 in your textbook if you want to study or refer points of this video back to the textbook. That's where you'll find it. Now, we finished off, we talked about bioaccumulation and biomagnification and how this particular pesticide we were talking about, DDT, was actually introduced into the environment. It accumulates within individual organisms, and that's bioaccumulation. And as they're consumed through the different trophic levels of a food chain or food web, then that's how we pass on this toxic substance, and that's called biomagnification. So DDT, though, was introduced, and it was created, remember, by Paul Mueller. But what it is, it's dichlorodiphenyl trichloroethane, and I put that up there for you to try as well. But it's a persistent pesticide, so it's introduced into the environment and actually stays in the environment for a very long time. The longer a toxic substance stays in the environment, the greater chance it's going to be consumed by other organisms, and then it's going to continue to be passed on. Now, DDT actually has a half-life of 15 years, and you can find that right here. Now what that means, that is, if I introduce 100 kilograms of DDT, after 15 years, if you just take a look right here, half of the half of the amount is still remaining in the environment. But if you take a look down here, actually, if we were to go about 100 years, after 100 years there would still be 100 kilograms of DDT still remaining in the environment. And the cause of that is because of bioaccumulation and biomagnification. So we introduced these things. They used it specifically for insects, but then they found that it was being consumed. It was entering in the environment and being consumed by other organisms, and it was being passed along the food chain and throughout the food webs, and it was accumulating within individual organisms, and then through biomagnification was becoming a huge issue as it spread and remained in the environment for years and was passed on through the consumption of different organisms within the different trophic levels as they moved up. So quite a problem. But there was a scientist by the name of Rachel Carson, and that's who this lady is here in these pictures. And Rachel Carson actually wrote a book called The Silent Spring in 1962. And in the 60s, she started to examine and bring attention that there were very harmful effects of DDT use in the environment. And so in her book, she basically said that we're poisoning our environment, we're poisoning our animals, because it's being passed along through biomagnification. It's being passed throughout the different organisms within a food chain and a food web, and she pushed to put a stop to DDT use, whether it be spraying or as a powder, and to ban the substance or the pesticide. And so I believe it was actually banned in 1969, and you were not allowed to use DDT anymore. So that's a background on DDT and its effects. So it could be in a powder form, a liquid form. You could spray it, condense and spray. Its half-life 15 years, stayed in the environment for a very long time, and Rachel Carson was very influential in standing up and saying we need to put a stop to DDT use because it's causing harmful effects in the environment. And we're going to see even more implications of these effects further down as we move forward. Now, the problem with the DDT, though, was it was containing or it was decreasing the number of incidents of diseases such as malaria. Now, remember back that malaria was a disease caused by those pesky mosquitoes. And so what happened was, like in Zanzibar, okay, they were controlling malaria. It dropped from this 70% to 5% in over 6-year span because they were killing all the mosquitoes and then malaria. So cases of malaria went down significantly and thus causing less deaths. But then they put the restriction of DDT in 1984. And then we see the incident of malaria after that. They implemented and said, no, you cannot use DDT use anymore. And they restricted the use of DDT. Then it saw it bounce back up cases of malaria in that area up to about 50 to 60% level. Now, they hadn't found anything else that was as effective in controlling malaria at that point. So my question to you is repercussions on the environment versus controlling diseases spread by organisms in the environment. Should DDT be banned completely, or should it be used still? And that's a question that's being asked, and I'm not asking you, but that's the discussion still. So one thing we have to keep in mind, if you just draw your attention down here, is producing safe and effective insecticides as alternatives to using DDT. There's a few things that make it difficult. One, the cost is great. Two, its overall effectiveness. And three, what if there's resistance within the environment to these sprays being occurred, or what if there's resistance even in society to using these pesticides? So DDT, one, it got banned because of the harmful effects of the environment, but then all of a sudden now we saw an increase because it was so effective in controlling things such as malaria or typhus, and then we see an increase of these diseases starting to break up, so we see more deaths or illnesses with regards to these diseases. So it begged the question, should DDT be banned completely, or should it be a partial ban? And these discussions still go on today because using pesticides is so widely used throughout the world now. They still have to think what's best for the environment, because without the environment we would struggle to sustain. Oops, there goes my pen. Alright, so here's a whole handful, a lot of writing, but we can just sum that up. So where to now? Basically, we use these pesticides to control, such as insecticides to control pests, but now what we're doing is we're targeting a specific group, but we're having harmful effects on various other groups. And so there's a lot of research that's being done to try to develop these new pesticides, and what that's resulted in is pesticides, they're breaking down faster in the environment after they're applied. So instead of staying in the environment or having a half-life of 15 years, maybe the half-life has been decreased significantly with less years. And so we also want to, there's just been a lot of research in these areas, and people and scientists are trying to determine or to develop safe pesticide creations and applications and make sure they're environmentally friendly. But it's a hotly debated issue still, and it's going to continue to be a hotly debated issue, and I'm assuming scientists are going to continue to keep the environment in mind, but still try to find a way that we can keep productivity high in crops, prevent disease, prevent the spread of disease through insects and such, and then also make sure we're safe to the environment while we apply these pesticides. So that's basically the story of DDT, and also leading into where we are today in society after it's been restricted. What direction do we head? What's been done, and what are some researches that have been that are being carried out to create safe applications of pesticides, and pesticides that don't stay in the environment so long and that break down quickly and easily. So anyways, this was part 2. Hopefully this has helped, guys. This is the last of the screencasts in topic 2. I'd really like you to write notes on these as well, and make sure you have that for your own reference. And hopefully this has helped. Thanks for tuning in, guys. Bye.